back to my YouTube channel. So in this video, I'm going to show you, this is example 5. We have already covered 4 examples on sum and difference identities of the trig functions, which involve the sum of the sine, sum of the cosine, and sum of the tangent as well. So this one is slightly different than the previous 4 examples that we have covered. So let us see how we can actually do something like this. Okay. So after we are done with this example, then I'm going to move to more properties, especially I'm going to move to the half angle properties and the double angle properties, and then we will also try to solve some examples based on those two identities as well. So let us look at this example. In this example, you can see that the cosine of beta is already given to us, -4/5. And guys, the most important part of the information here is about the angle. So it here specifies that the angle beta in the first case is between pi and 3 pi over 2, which basically means that angle beta is between 180 degrees and 270 degrees. That already tells us that the angle beta is in the third quadrant, right? We divide this into 4 quadrants. So first quadrant is from 0 to 90, second is from 90 to 180, third is 180 to 270, and finally the fourth one is 270 back to 360, which is going to overlap with the 0, right? So the first angle is restricted. It is going to be in the third quadrant. It's already provided to us. And then when we look at the cosine of alpha, which is -2/5, then it also specifies here that the alpha is supposed to be between pi over 2 and pi, which means alpha is supposed to be between 90 degrees and 180 degrees. So which means alpha is in the second quadrant, okay? So based on this information, we have to evaluate the cosine of beta minus alpha, okay? So the first thing that we would want to do is we'll start by the cosine of beta information, and from there we can start drawing things, okay, drawing reference triangles. We'll draw reference triangles for both of them, and then we'll go from there. Even before doing that, I think what we should do first is we should go back and look at our formula sheets. If we do not remember the cosine of the difference, if you remember, then we'd go ahead and just write it out, or we can look at the formula sheet, and from the formula sheet we should be able to get the formula for the basic trig identity cosine of a minus b. So cosine of a minus b, in this case beta minus alpha, is cosine of beta times cosine of alpha, right? And then there's a plus. Remember, if there's a minus here, you got a plus. Then we have the other two pieces are going to be the sine of beta and the sine of alpha, okay? So we should first write it out. So based on this information, cosine beta, cosine alpha is already provided to us. So we can simply replace them by these given values. But we don't have the sine beta and the sine alpha. So we have to do some extra work to figure out sine beta and sine alpha. Then we bring it back here and then we simplify, right? So let us first start by drawing the reference triangle here. So keep in mind, since beta is between pi and 3 pi over 2, so my reference triangle is going to be in the third quadrant, so it is going to look something like this. This is my reference triangle. So this whole angle is supposed to be my beta, right? This whole angle is supposed to be my beta, but for simplification purposes, guys, we can just call this as beta, just for simplification purposes. And based on this information, we know that if this is my reference triangle and this is my reference angle, then this, of course, the longest side is still going to be my hypotenuse. But keep in mind, guys, when we think in terms of going through the whole 4 coordinates, then we think in terms of the unit circle, okay? Or, sorry, in this case, it would be like a circle, okay? So when you think about a circle, then this is thought of as the radius, which we also know in terms of that right triangle, it is the hypotenuse, okay? So it is the hypotenuse, or here, if we think of a circle, then it's the radius. And then this is still going to be my opposite side, and this side is going to be the adjacent side, okay? So 3 sides of the right triangle, opposite, adjacent, and hypotenuse. Instead of calling it hypotenuse here, we like to call it radius. Now from here, from the given piece of information, we have, let's see what we have. We have cosine of beta is -4/5. But we already know that the cosine, so remember the SOHCAHTOA, from that we already know that the cosine is adjacent over hypotenuse. So in this case, I would say it's adjacent over the radius of that circle, right? So that already tells me when I compare this with -4 or 5, that means my r or hypotenuse is 5, and then the adjacent is going to be -4. Let us make sure that the signs are correct. Guys, this is x-axis in the left side, so x is supposed to be, the values for x are supposed to be negative, so it makes sense to have a -4 here. This, the radius or the hypotenuse, is always going to be positive. And then the only thing we have to figure out here is the opposite. And we know it's a 3, 4, 5 triangle, right? There's nothing really special about it. And you can use the Pythagorean theorem also, if you like, to find the opposite side, right? So it's going to be 3. But guys, here you have to be very careful. It is not just going to be positive 3, it's going to be -3, because this is in the negative y direction. So you have to follow those signs here, right? You cannot just put a 3 here. So it's going to be -3. That's the only important thing in this example. Otherwise, this example is pretty similar to example 4. But here, because it's in different quadrants, you have to be careful with the signs. And we know where the x's are negative and where the x's are positive, where the y's are positive and where the y's are negative. So you have to be consistent with those things, okay? So we have the opposite, we have the adjacent, we have the radius. Based on that, we can easily write the sine of beta. Sine of beta is what? It's opposite over hypotenuse or opposite over r. So in this case, it would be opposite is -3 and divided by 5. That is the sine of beta. So we have these two. Now we also have sine of beta. All we need is sine of alpha. Once we have sine of alpha, we put it all together and then simplify. So to get the sine alpha, you basically have to do the exact same process. You have to draw another reference triangle for this information, but keep in mind here alpha is between what? Is between 90 and 180. So it's going to look like this. This is my coordinate axis, then my angle alpha is in the second quadrant. So let us say this is my reference triangle, and although this whole angle is, sorry, this angle is alpha, but we can consider this to be alpha for simplification purposes. And based on the information, cosine of alpha is -2/5. We know that is adjacent over r. So let us label this carefully. This is going to be 5 again. I mean, there's a 5 here, so radius or hypotenuse is 5. Then the adjacent, this is going to be the adjacent side, so it is -2. Does it make sense to have a -2 there? Yes, because we are on the left of the origin, right? And so x values are going to be negative. And then we got to find the opposite, okay? So in this case, it's not a special triangle. So we got to do some work to figure out the opposite, and which is pretty simple. You still have to use the Pythagorean theorem. So using the Pythagorean theorem, it would be, the opposite would be square root of the 5 square minus -2 square. So it's like 2 square, because square is going to just take away that negative anyway. So opposite is square root of 25 minus 4, which is square root of 21. Well, we cannot simplify square root of 21 any further, so we got to leave it like that, right? Because 21, what are the two factors? 7 times 3, none of them are perfect squares, so that means we cannot really simplify this. So we got to leave it like this. That means the value for the opposite is radical 21. I have all the sides, so, and it is going to be positive because it's above the x-axis, right? That's why it's going to be positive. Now let us see if we can write the sine of alpha. Sine of alpha is opposite over hypotenuse, or in this case opposite over the radius, and opposite is radical 21, and we got to divide that by 5. So guys, we have basically everything that we need. So let's bring it back together. Cosine of beta, -4 over 5, times cosine of alpha, which is -2 over 5, plus, then let us fill this in, sine beta. What do I have sine beta? -3 over 5 times. Guys, I like to circle these things because when I go back and bring them back here, then it's easier for me to actually see them, okay? Times radical 21 over 5. We just got to now just simplify this. -4 times -2 is positive 8 over 25. And then here we are going to end up with negative, because positive times negative is negative. Well, we cannot do much with 3 times radical 21, so we just got to write that as 3 radical 21. 5 times 5 is still 25. Guys, we have the same denominator, so when we have the same denominator, we just combine the numerators. 8 minus 3 radical 21 over 25. That is the final answer for cosine of beta minus alpha given this piece of information. So guys, it's not too complicated. All you have to be careful with is the fact that when the angles are restricted, so you have to draw these reference triangles in that particular quadrant. You cannot just draw them in the first quadrant. In the previous example, if you go back and look at my video, or if you have already checked that video, it was all in the first quadrant between 0 and 90, so everything was positive in that case, right? So in that case, everything like all these cosine and sines were positive, so that way we were able to simplify things. Here, some of them are positive, some are negative based on what quadrant they are, and you first draw those things and then you bring them back, simplify, and you get the final value. Okay, so guys, that's it for the sum and differences. Later, when we prove identities, we are definitely going to come back and use these sum and difference properties or difference identities again. But till then, this is it for sum and difference. In my next videos, I'm going to be talking about the double angles and then the half angles. Okay, till then, take care and keep practicing the sum and difference examples.